Okay, so I'm going to cover partial fraction decomposition. Just going to use the notes which are already scanned into your Schoology materials. So just a brief overview on how to add or subtract fractions. So it's the same idea when you're using any fractions. If you want to add or subtract, you need to get a common denominator. Okay, so how you usually get that, an easy method is whatever is missing from this denominator, this number here, you multiply this side by 5 over 5, the one that's missing over here. This is just equal to 1, so you're not 1 times anything, you're not really changing this number here. And over here, the same thing. Here you're missing the 7, right? The common denominator would be 5 times 7 on both of them. So here you multiply by 7 over 7, which is equal to 1. So you're not changing the value of this number, you're just changing how many pieces it's cut into, okay? So now you have a common denominator of 35 for both of them. Then you can add the numerators. 5 times 4 is 20 and 3 times 7 is 21. So you get this. Here's another one with subtraction, same idea. Here's one with a rational number, something more like what you're going to see. So same exact idea. What's missing from this one is this number over here, x minus 2. What's missing from this one over here is x plus 5. So you multiply this number by x minus 2 over x minus 2, which is still equal to 1, a number over itself. Same over here, x plus 5 over x plus 5. Okay, so this is just a fraction review. After you've done that, you've got a common denominator of x minus 2 times x plus 5. So you can combine the numerators, x times x minus 2 and 3 times x plus 5. You can distribute that if you want collect-like terms. You don't necessarily have to multiply these denominator linear terms here. So there's just another example here in the notes with the subtraction, same idea. You can look at that. If you need to pause the video, why don't you go ahead and do that if you need to look at those. So let's do our first example. So let's just be clear about what we're doing first. When we're talking about partial fraction decomposition, we're talking about taking the combined fraction and decomposing it to the original parts here. Okay, so what we've done on these other ones, if we've taken two smaller fractions, we combined it into one. Decomposition, like decompose, we're breaking this apart into the smaller pieces over here. Okay, so we're going to take the larger one and decompose it into smaller pieces. So here are the steps to do this. The reason you might want to know how to do this in calculus, it's probably easier to work with some of the simpler fractions rather than the really large and difficult, more complicated fractions. So here's step one. You're given a rational fraction here. What you want to try to do, step one, is to factor the denominator. Okay, you don't really worry about the numerator. What you want is to factor the denominator. So again, this is a quadratic. Hope you can factor a quadratic. Okay, now we have two linear terms here. Step two, you would set up temporary numerators for each factor in the denominator. Okay, so here we're just using A, B, C, D, E, F, G, whatever, like that. Okay, so A over the first one and B over the next one there. Okay, now once you've got the temporary numerators, your third step would be you want to try to get rid of the denominators, try to get rid of making it a fraction. So the way you do that is you multiply everything times the common denominator of all of these, which is usually the most complicated denominator over here. Okay, so when you multiply that, you distribute it to each one because it's an equation. Okay, so when you multiply this times the first term, what happens are the x plus 2 and the x minus 1. That's x plus 2 over x plus 2, x minus 1 over x minus 1. Those two reduce out to 1 times x plus 5. So your first, you're just left with the numerator there of x plus 5. The second one, if you distribute that over here, the x plus 2 is going to cancel out, and you're left with a times x minus 1. Okay, and the third one, the x minus 1 is going to cancel out. X minus 1 over x minus 1 is 1. So it will just be b times x plus 2, right? B times x plus 2. These two cancel. All right, now you've gotten rid of all the denominators. There's no more fractions. So now all you do is a little bit of algebra going on here. Just distribute here, a times x, a times -1, b times x, b times 2. And then once you've gotten that, you would collect the like terms. Okay, so put the x's together, factor out an x. Okay, so ax plus bx, to factor out an x, there will be a plus b. And then you have these constant terms here, collect those together. And now you are ready to set up your equations to find out what your a and b are. So the way you do that is you set the coefficient of this side of the equation to the coefficient of this side of the equation. We're looking at the coefficient of this x, the coefficient of this x, the coefficient of this constant term and this constant term. Okay, so you just set them equal to each other. There you go. So if you don't see a coefficient, that number would be 1. If there's really no x there, or no x squared, for example, it would be 0x squared. So here you go, 1, the coefficient of that x and the coefficient of this, and 5 equals negative a plus 2b. Now you have a system of equations. Here they are. Here's the two equations right here. So now you just solve the system of equations. Okay, you've got actually two equations with two unknowns. Okay, you solve it the way that you know best, with substitution or elimination. It doesn't matter. This one would be even easy with elimination, right? Because you just add them together, the a's would cancel out. Okay, whichever way you find easiest, as long as you're showing your work. You can look at this. This is about solving systems. If you need to, pause the video now and you can find out how you can look at this. There's no one way that is better than another. Maybe you saw that a equals 1 minus b here, for example, or maybe you saw that this was an easy way to use elimination. Whatever, this is one way of doing it. Okay, so you can pause and look at that if you want to. The important part is at the end, you come up, no matter what you do, we should all come up with the same answer. We got an A and a B answer. So you would just go back to the original equation that we had, that we set up right here, and you replace the A and the B. Now that you know what they are, this is your final answer right here. This is the decomposed fraction of this right here. Okay, now we're going to try another example. This is the second example we did in class. Same idea, not to get overwhelmed. All we're really worried about is decomposing this large fraction. All we're really worried about is factoring the denominator to start with. So I hope you see there's an x in every single term here. So that's where this came from. Once you get the x out, you're left with the quadratic, which was factored here. Okay. If you need to know how to do that, just you can always use the quadratic formula to factor that out. Okay. Once you've gotten this factored in the denominator, don't worry about the numerator yet. Just do the denominator. Now you can set up your temporary numerators, one for each linear factor in the denominator, A, B, and C. So in this case, you have 3 unknowns. Same idea, we want to get rid of all these fractions, so we're going to multiply by the common denominator, which is this one right here, right? It has all of these 3 terms in it. So you multiply it by this more complicated one, distribute it out, right? In the first case, all of those would cancel out, equaling 1, and you'll be left with just the numerator, which is that. The second one, the x is going to cancel out, and you're left with a times 2x minus 1 times x plus 2, these two distributed to the a, right? The next one, this one term would cancel out, so you're left with b times, over here, distributing towards that b, x times x plus 2, and the c, the x plus 2 would cancel out, So c times x times 2x minus 1. You're distributing that to each one of these terms. Now, after you've done that, you're going to have to do some algebra here, which is multiply these together, multiply all of these together. First, I would FOIL this out and then distribute the a. Here you can distribute bx times x and bx times 2, cx times 2x, and cx times -1. So here, this whole thing, I FOILed it, first, outer, inner, last, came up with this. Okay. Now you can distribute that a, right, this big giant distribution. Now collecting all the x squareds together, all the x's together, and then all the constant terms together. That's it, I think, right there. Yes. So if you collect all of the x squareds together, right, and you factor out the x squared, you're left with 2a plus b plus 2c, okay, times that x squared. Now all the x's, so factoring out the x, you're left with 3a plus 2b minus c, okay? And then the last one is just the constant term, which would just be minus 2a, and that's it, okay? So you've got the coefficients of your x squared over here is 1. This is the coefficient for your x squared over here. Coefficient of your x term on this side of the equation is 2. The coefficient for your x over here is 3a plus 2b minus c. And the constant term, think about it like this, x2, x1, x0, x to the 0 is equal to 1, right? So this is your x to the 0 coefficient, -1, and over here, -2a. Okay, now you've got your system of equations you can set up. There they are, everything that we just said. 1 equals 2a plus b plus 2c. 2 equals 3a plus 2b minus c. And -1 equals -2a. Solve your system of equations. You've got 3 equations, 3 unknowns. All right, so do it whatever way you can think of that works best for you. Substitution, elimination, a combination of the two, just as long as you're showing your work. So if you want to pause now and work on that system, you can. Here is a worked out example. Not the only way, again. You can pause the video now if you want to look at that. An alternate way of doing this is to set up a matrix on your calculator, but we're not going to cover that this year. We are going to require you to solve it with the system because not everybody has a calculator with matrix operations on it at home, so it's not fair. But if you want to know how to do it, here's your 3 equations. You set up a 3 by 3 matrix in this case, right? 1, 2, 3, 1, 2, 3. And a 3 by 1 matrix, and you do this operation on your calculator. For the TIs that we have at school, these are the steps. You can pause this if you want and try it out, but you do this A inverse, after you set up the A matrix, A inverse times B. Okay, and then when you get your answer on your calculator, it should look something like that. Okay, so that's the A, the B, and the C in that order. We also did it with solving, which is what we're going to expect you to do. There's the A, the B, and the C. Plunk those numbers in for the A, the B, and the C. And then this number right here, you can drop down below to the denominator. Drop that down. Make sure you distribute it or put parentheses there on the denominator. Same with this, 10 times x plus 2. Okay, and there you are. This is this giant fraction decomposed or broken apart into these 3 fractions here. Now we're going to do, we have 2 more examples. Now we have one with multiplicity. If you have multiplicity, that means you have a linear factor there that has an exponent. That's the multiplicity, is the exponent. That's all that's meaning. So it's looking like this, same idea, okay? So everything about this is the same. You just have a little bit, one more step here, which is if you have a multiplicity of a factor, you do A over one of those and then B over all the way to however many times you have it. So if this was x plus 1 to the fifth, you would have a over x plus 1 plus b over x plus 1 squared plus c over x plus 1 cubed plus d over x plus 1 to the fourth plus e over x plus 1 to the fifth. Okay, so every time you have a multiplicity, you have to do one for each exponent that you have here. Okay, after that, it's all the same, all exactly the same. You are trying to get rid of the denominator by multiplying by the common denominator. So here, these two cancel out. Here, one of these cancel, and here, these two cancel out again, right? X plus 1 squared divided by x plus 1 squared is equal to 1. Okay, so you're just left with 2x plus 3. Here, one of them cancels. A times x plus 1, and here they both cancel again, plus b. Same exact steps here. Distribute, collect your like terms with the x's together, the constants together. Set up your temporary equations. So coefficient of the x's to the coefficient of the x's, right? A equals 2. That's 1 already. And then a plus b equals 3. Okay. If you had to do a matrix, we'll do that another time. You can look at that in your calculator if you need to, but this is pretty simple, straightforward right now. So you get your final answer, plug in your A and your B. Okay. That's just what I was talking about. If you have x plus a to the fifth power, it's 1 over x plus a. Whatever, a over x plus a, b over x plus a squared plus c over x plus a cubed, all the way to x plus a to the fifth. Here's an example of if we give you the graph of this, so it's kind of factored out for you, right? This is an x to the third equation. Here you have a bounce. So this is x plus 1 squared, minimal, right? Squared, and this is x minus 2 to the 1 power because it's passing, right? Odd, even with the bounce. Okay, so there is this one factored out, a over x plus 1, and then b over x plus 1 squared, right? Because it's the multiplicity of x plus 1 is squared. So you have it over the first one and then the second one squared. And then the last one you're passing through. Everything else is the same. Okay, right? Get rid of the denominator, distribute, collect like terms, set up your system of equations. Good. Last one. So there it is. System of 3 equations, 3 unknowns. So you get your A, B, and your C there. You can, if you want to try this out, sorry if I went too fast. If you feel like working this out, stop now, pause it, and then work it out. Here's your final answer right here. You can pause it and work that problem. Now we have the last one, which is an irreducible quadratic. So what do I mean by that? An irreducible quadratic means you cannot factor this anymore. In every single example we've done so far, we've been able to factor to linear factors. In this case, how would you know? I've had some students asking me that. How do you know you can't factor this anymore? Well, if you put this A, B, and C, right? A equals 1, B equals 1, C equals 1 into the quadratic formula. Let me write it down for you so you can see it. Say you come up with this, oh, I don't know how to factor this. I'm not figuring it out in my head. I don't know how to do that. Remember, it's ax squared plus bx plus c for a quadratic. So here you have a equals 1, b equals 1, and c equals 1. Okay, so you can always use our friend, the quadratic formula. Okay, so if you plug that in there, let's see, opposite of b, so opposite of 1 plus or minus the square root of b squared minus 4 times a times c all over 2 times 1. So that would be negative 1 plus or minus 1 minus 4 would be negative 3. all over 2. So I want you to look at this part right here. Right here. That is what's telling you that you can't reduce it by that. Remember, if you take the square root of negative 3, that's the same as the square root of 3 times the square root of negative 1. Okay, you can't reduce that anymore, so it's root 3. And if you remember, this right here is equal to I. Okay, so what you're going to end up with is negative 1 plus or minus root 3I all over 2. This is what I'm talking about. We do not want to have imaginary answers. That's not what we're talking about when we factor. Okay, we're talking about nice, clean, real number linear factors. So if you end up with an I when you're trying to factor a quadratic, that's what we mean by irreducible. So you can always check with this. Okay, always. So if you've come down to this, you can't factor it anymore. You're ending up with I's in your answer. This is what you do. Okay, you still set it up. By the way, here is also this. We need to recognize difference of squares and difference of cubes. So if you want to copy that down for a second, here are the factorizations of a difference of cubes. Here's an example. Just pause the video for a second and copy those down. This is difference of squares. Okay. Don't worry about that. That's just a little tip there. Go stop the video if you need to copy that. Other than that, we have to recognize a difference of cubes, which factors to this. This is irreducible. You can't factor that anymore. You tried it with the quadratic formula. It doesn't work anymore. So this is what we're going to do. We're going to set up A over the first linear factor as we're used to. But now we have a quadratic factor. It's not linear anymore. So what you have to do when you have a quadratic factor, which you can't factor anymore, is you write whatever letter you're on, A, B, C, D, or whatever, but bx plus c in this case. Does this not look like the equation of a line a little bit? Look, linear to constant, quadratic to linear. It's one below the denominator, okay? If you were on D here, this would be EX plus what? EF, right? EX plus F there, okay? Just whatever letter you're on. So something X plus something, the next two letters that you're coming into, okay? The rest is all exactly the same. Get rid of the denominator by distributing the common denominator out, right? And this one, these two cancel out. And this one, these cancel out. And this one, the quadratic cancels out. Okay, so you're left with 3x minus 5, a times x squared plus x plus 1, and bx plus c times x minus 1. Distribute, collect the like terms, set up your system of equations, okay, and then solve with your system of equations. I do believe I have that here. You can look at this. This is what we worked out in class. So here, if you want to look at the system of equations for that, I believe it's the same thing, right? Yes, it is. Same problem. So if you want to look at that, pause the video, and there's solving for your system of equations. Just stop the video for a second. This, again, this is not the only way of doing this. Some people solve elimination. Some people substitute it in differently. That's all fine. But no matter which way you do it, you should end up with the same answers. Okay, after you've found those answers, the A, B, and the C, 3 equations, right? 1, 2, 3 equations, right? Here's one thing to remember on this. This side of the equation has no x squared terms. So if you have no x squared terms, you're going to put in 0. We have no or 0 x squared terms. So that would be the coefficient for the x squareds here, the x's, and the constants. Okay, x2, x1, x0. All right, so 3 equations, 3 unknowns. Stop. if you need to look at this. In the end, you have your A, B's, and C's. Okay, so A, the B, and the C, right? A, and then there's that BX plus C there. So remember that number you can plunk down below. Here you've got a common denominator. So look, 2x, there's a little bubble for you right here, okay? This 2/3 x, that's the same as 2/3 times x over 1. X is the same as x over 1. So that's 2x over 3. Okay, so now you have a common denominator of 3. So that's 2x over 3 plus 13x over 3, which is the same as 2x plus 13 all over 3. Now that you have one common denominator, you can bring that down below. Okay, and there it is. Just pause this if you need to look at it for a second. And we are done with this little review of partial fraction decomposition. Thank you very much. And I need to stop this.